Today is 16 April and we have today quiz. We will talk about it a little bit later. First of all, I wish to tell you that I am very glad because of video which I did upload last week, collect 52 viewers and 6 was positive response. That is very nice and I will try to continue upload such a video to help you to understand material. But of course you should understand that without your efforts efficiency of study will be not so high. Talking about today program, so we should tell following. Today you will have possibility to answer for question in quiz biogas and biofuel. Also, I upload page when you can put your question regarding today quiz and material, because of from last week you have to read material also about biofuel. Material about biogas I partly answered last week, but if necessary I will try to make additional explanation. What also new appear in our page for this chapter? I put material about taxonomy. That is a new tool for sustainable development, and that is discussion about how investor can select best possible solution for green energy development. I will not go deep in detail about this material because of if you will have some question we can discuss it later on. I just wish attract your attention that development in Europe is going about transition to green energy, and partly it will be related also to a different tool development. Talking about biomass, we should say that all time gave us new challenges. For example, I find such information about USA situation. Billions of dollars of food is going to waste during coronavirus epidemic. So that is a perfect source to produce some green energy with no emission. So let's look a little bit about material which was uploaded in file biofuel. So first of all we have to understand that about generation from biomass we have 3 or even 4 generations. The first generation was biomass can be used as food supply. So what you have seen in previous pictures. Second generation, wood. So wood material, lignocellulosic, we can convert to biomass and recover from waste, recover energy, but not by combustion, by synthesis we will produce fuel. Third generation, genetically modify crops, algae, which is growing fast and produce very fast energy. And also here we have to add fourth generation, when genetical modification will produce directly fuel. Of course we have to understand that nowadays only first generation and second generation is used in practical way, but third and fourth generation mainly exist in laboratory and in plants. So then also we have to understand the large variety of biomass. So that can be energy crops, food and feed residues, some certain waste after wastewater treatment, it's one of the way. So, and of course forestry. So, but talking about forestry, we have to be very careful about sustainable development. We should not initiate deforesting. which you did ask me last questions, so last time. So then introduction of definition. Biomass is all mass of organic origin which is not of fossil nature. By the way, I would like to tell you that in my material I use different source and I didn't show every time origin of the source because of this presentation is used only for our lecture. It's not, let's say, public materials. So then, introduction, sort of biomass, energy crops, organic rest streams, so rest wood from forest, remainder from wood, industry, manure from cattle and so on. Paper, textile also can be source for energy. Biomass, conservation of solar energy. It's very important to understand that all source of energy in our Earth is a solar radiation. And if we will convert, let's say, solar radiation in a different way of energy, then we can find different efficiency. We can read conclusion. Only about 5% of total solar radiation reaching the growing plant and only 0.6% of original total annual energy. So it means that it's probably much easier to use direct solar radiation by way of photovoltaic panel than to use biomass. But anyway, we have to understand this way of energy conservation as well. Talking about available technology, we have number of ways: thermal, chemical, physical, chemical and biochemical technology to do conversion of biomass to energy. So there is a quite complicated table which you can study yourself, so biomass conversion by different technology, and here we can see all different products. So we can produce steam, gas, oil, charcoal, biogas. We can produce also liquid fuel by distillation and also biodiesel and ethanol. So, and at the end we can get by biomass conversion three main way of energy: heat energy, electrical energy and fuel for transport vehicle to replace fossil fuel. So biomass conversion, you could see also different way how to do it. So there is a different sequence. And also I wish to attract your attention to one of the ways, that is producing hydrogen. And another thing is that hydrogen we can use not only by way of combustion, but also to feed fuel cell, which we will discuss a little bit later, what is a new technology and quite efficient. Another thing which I would like to attract your attention, that is a kind of biogas, that is a so-called landfill gas. So that we will talk a little bit later. So main idea is that carbon which is coming from crops, sludge, other source, we can convert in different shape of oxide and monoxide, so which can be used as generator gas, methane and also hydrogen. So that is mainly by thermochemical conversion. When we was talking with you about wood gasification, so-called wood gas or water gas, so you have seen this technology. Also, I would like to remind you one movie which I put here, so that is about wood gas car. So this wood gas car was quite popular during Second World War, when liquid oil supply was quite limited for civil people, and so this technology was quite popular. Now some let's say, enthusiasts are doing similar experiment, and you could see this result yourself. So, but we will continue. Sorry. So gasification we did discuss, and you had to understand that basic gasification is substoichiometric oxidation. So about stoichiometric oxidation we will talk in another subject in thermodynamics. So here you could see, well, flow sheet of different process of gasification when we can convert biomass to different product, so to methane, carbon monoxide, and also to methane. So by different technology, drying, pyrolysis, reduction, tar decomposition, and so on. Also, we have to understand that gasification process can be realized not only in small scale, but also in big industrial equipment. So, and technology can be quite different. For example, CFB, that is circularized fluidized bed. So this technology are used for big boiler, which we will see little bit later on. So then conversion to secondary energy carrier. So that resulting gas is used to CHP. CHP, that is a combined heat and power. That actually will be our next topic next week. So most advanced system can be biomass integrated gasification and then steam injected gas turbine. Unfortunately, scope of our subject not allow us to talk a lot about this technology feature. So, but you can read yourself in thermodynamic course the basic things like Rankine cycle and Brayton cycle for gas turbine. Another possibility to avoid harmful emission and increase efficiency is so-called integrated gasification combined cycle. So, and in this device we can produce so-called synthetic gas even from coal, which can create a lot of pollution, but by the way of integrated gasification combined cycle we can significantly reduce emission and make coal much more friendly for environment. So in this picture you can see a different design of gas generator unit. So from left side you can see industrial gasificator, so, and you could see fuel supply and gasification agent, so that is a, let's say, air, or it can be also oxygen, but main idea is that we will do let's say not complete combustion, and as a result we will produce synthetic gas which we can use for different applications. Residual material we will remove from device from bottom, but you should understand that of course during this process losses is unavoidable, and because of that, so the energy which we will get with synthetic gas will be less than energy which we will supply with the fuel. So that is unavoidable. Then we can have very different arrangement for production of synthetic gas. So, but that's again not inside scope of our project, so you can consider it little bit separately. So another way to produce liquid fuel is to produce ethanol from energy crops, and ethanol become quite popular nowadays. So about 5% of all fuel for car is bioethanol. So, and source for ethanol production is maize or corn harvest. So, and you could see that ethanol and biodiesel have limitation as liquid fuel, performing poorly in cold weather and capable of damaging unmodified engine. That we should definitely take in account. So, Making second generation biofuel mean overcoming three challenges. So that second generation, as I did explain you already, that we can make direct generation from non-food stuff, not food biomass. So the first is break woody cellulose and lignin polymer. So the second is convert those sugar into drop-in fuel, so to suit existing vehicle. And third is largest challenge is to find way to do all this in cheap way and in large scales. So, and I'm pretty sure that technology is possible to develop, but main thing is of course to make it price acceptable, especially nowadays when price for oil is going very low. So then you could consider also a different way of physical chemical conversation. So biochemical conversation with anaerobic, so or without oxygen anaerobic. So and then we have some consideration of alcohol fermentation, production of let's say ethanol, and also we can have also anaerobic digestion, and using waste treatment we can produce methane gas. Methane gas we will produce in anaerobic digestion, so-called gasification, and this process especially good developed for sewage water treatment. So it means that all wastewater which come from city should go through treatment, and during treatment we get solid sediment, and treatment of this solid sediment will create so methane gas which can be used like a fuel. So another possibility is used vegetable, fruit, garden, other residue from which we can produce biogas. So this biogas will consist of 55 to 60% of methane, and rest will be carbon dioxide, because of that calorific value of this biogas is not as high for original natural gas. Another possibility is produce liquid fuel. It is a synthesis by using Fischer-Tropsch process. So this process was very well known already more than 100 years. So, and it was especially actively used during Second World War, again to produce liquid fuel also from coal. So, and let's say here we can see, well, schematic representation of this Fischer-Tropsch process, and you could see that using carbon monoxide and adding some hydrogen, so we can do synthesis of carbon hydrogen, so that is methane. And also if we will increase number of molecule, then we can produce also liquid fuel, as you could see in these pictures. So gasification technology established to convert feedstock, and also to treat coal and crude oil. So that's also a way to use Fischer-Tropsch. Pyrolysis, established technology for decomposition of organic material. We have separate presentation for gasification. Pyrolysis, you can find some more details there. So fermentation to produce ethanol. That's again we have used anaerobic biological process to develop ethanol, liquid ethanol, and later on we can use it together with gasoline, so or use pure ethanol. It depends on situation. So, and production of ethanol, especially popular in USA and Brazil. So, and you could see that there is a different process which can be used to produce liquid ethanol. So also one of important part in production of bioethanol is to make it pure from different additive like gums, because of such, let's say, additives can reduce quality of fuel. Very important to understand that energy content of ethanol is approximately 24 megajoule per liter. 24 megajoule per liter. So that is not very much, that is not very high. And also, if we talk about cost of fuel, you could see the dollars per liter of gasoline equivalent. You could see that unfortunately still ethanol from cellulose, like its second generation biofuel, is quite expensive. Ethanol from grain, ethanol from corn is some average position, and ethanol from sugarcane is much cheaper, so in Brazil. But of course the three cheapest kind of fuel is produced from food stock, and how to say, that is a, let's say, first generation, and we should try to make more acceptable price for second generation of biofuel, so ethanol from cellulose. Then you could see that production of ethanol yield for different, let's say, raw material. You could see efficiency yourself. So then also we can see that process during which we are producing this ethanol and what kind of residue we have. Also, it is possible to produce culture cellulose ethanol. That is our future, so technology. Ethanol had 67% of energy content of gasoline. Biodiesel have 86% of energy content of diesel. That we should bear in mind. That ethanol have less energy than diesel than origin gasoline, and because of that consumption of ethanol expected to be higher. So then we have discussion about biodiesel production. So also full life cycle for carbon intensity. We have understand one thing, that to produce, let's say, a biofuel, we need to produce some certain crops, for example soy, and for this purpose we have to use quite a lot of water. And you could see this table that for different culture we need quite different amount of water for production of 1 gallon of fuel. And you could see this figure that to produce from soybean biodiesel, to produce 1 gallon of biodiesel, we have to spend up to 2,000 gallons of water. So for ethanol it is around 324, for corn ethanol 268. So all these things we should take in mind, because of when we consider biofuel as completely green, it's necessary to take in consideration also sustainability of process. So then we can have consideration of second generation technology, and basic idea that we can use thermochemical, biochemical routes, and we can use, let's say, technology like BTL, biomass to liquid, or GTL, gas to liquid. So also we can consider way HTU, hydrothermal upgrading. Diesel is produced from wet biomass. There is different technology, but all of them need to be still, how to say, commercialized. So then, if we will consider different emission from, how to say, different energy source when we are using for example, for steam turbine, so straw for forest residue and other kind of, let's say, wood material. Emission can be quite different. So, life cycle of greenhouse gas emission. So what we can see here that emission from coal is the biggest one. To produce, let's say, 1 megajoule of energy, we have to make emission around from 400 to 500 gram of carbon dioxide. For oil, natural gas, it is smaller. But if we use biogas or biomass, it is still will be some certain emission. So then we have comparison of how much we can produce, let's say, biogas, let's say biomass to liquid. It is a let's say diesel, then bioethanol, again ethanol from different crops, and biodiesel from different crops. And from 1 hectare, depending on energy crops, so efficiency will be quite different. The biggest if we will use biogas. Also, we can consider following efficiencies that using biomethane, we can make most miles from 1 hectare. So with average car consumption of biogas, so instead of compressed natural gas, 1 hectare can provide us 67,000 kilometers. But if we will use same area of land to produce bioethanol, so we will be able to make by car only around 22,000 kilometers. It depends, or plus, so 14,000 kilometers. It depends on efficiency of fuel use. Relative efficiency, so kilometer per hectare. You could see that is the smallest for biodiesel and biggest is for biomethane. So that can show you what is the idea of this taxonomy, which I tell you at the beginning. And so that shows us the most efficient technology and way how to best invest, how to say finance in bioenergy production. Then we can use palm oil to produce also energy material, but there is also some problem. The very interesting is way to use algae, so that is not normally foodstuff, and we can use direct, let's say, conversion of solar energy to fuel, so in such units, but it seems that it is a question for future. So that is explain how we can use algae for biofuel production sequence. So, and you could see that here we have quite small, let's say, technology treatment only on last step when we had to do transformation of fat to biofuel. So, and probably this way can be very attractive in future. So, fuel life cycle and again greenhouse gas emission. So, fuel life cycle emission. Here I would like to attract your attention to questions that when we talk about efficiency of biofuel, we have to take in account that we have to use energy for cultivation, for transport, for conversation, again for transportation, and only then we have distribution. So, and during all this step, of course, we will have certain greenhouse gas emission. So, thank you for your attention, and I wish you a pleasant quiz, and let's say awaiting your question. Thank you very much.